Hello and welcome to section 3.5. Today we're going to be looking at graphing linear equations in three variables. By the end of the day today, you should be able to graph linear equations in three variables as well as evaluate their functions. And then you're going to be able to use the functions of two variables to model a real-life situation. Solutions of an equation in three variables can be pictured with what we call a 3D coordinate system. Now, if you notice, a 3D coordinate system is going to have an x-axis, which is going to run along in this direction, a y-axis, which will run along this direction, and a z-axis, which is going to run in the vertical direction. And if you notice, our coordinate points now, and I know this is kind of small, but they will be represented with what we call an ordered triple. So we have our x, our y, and our z, instead of just a standard x and y. And if you look at what a 3D coordinate plane actually creates, we kind of get these planes like we would in a 2D, except in a 2D we're only getting the xy plane, which is what this green plane is. So by adding the third component, we now get an xz and a yz plane. As we mentioned earlier, each point on a 3D graph is called an ordered triple. Okay, the triple because you have the three components. And when you look at the axes of a 3D system, it actually creates 8 octants. We have one octant here, the second one here, the third one here, the fourth one here, and you can kind of see the fifth one, the sixth one down here, and the seventh one over here. And then the 8th one would be below this region here. So you do get 8 pieces to this system. Now our 3D graph paper is going to look a little different. And you'll see that I do have some of this over in the bin with the graphing paper. But it's going to look something like this. The easiest thing for you to do is to take a 3D graph paper, and I always start out by generating the z-axis, which is going to be the vertical axis. Then I will come in and draw in the x-axis, and the x-axis is going to run along in this direction. And then our y-axis is going to run along in this direction. So this is y, and we said this here was x. Now when we graph, this is the positive x, with everything back here being the negative x. Your positive y is this region here, and this is our negative y, and the positive z is in the upward direction, with the negative z being in the downward direction. So the positive quadrant is kind of the one that would be closest to you if you could see all of the planes there. Now if we look at example 1 tells us to plot two ordered triples. So the first thing, as I mentioned earlier, is we are going to go ahead and just draw in the axes. So here is my z-axis. Here is my x-axis, and here is my y-axis. So when I look at this point here, and it says -5, 3, and 4, I'm going to start out at 0, 0, which is right here, and it says -5 in the x direction. Well, I know that this is my x-axis, so that means I'm going to have to go 1, 2, 3, 4, 5. So this is -5. I'm going to go 3 in the positive y direction, so 1, 2, 3, which puts me here, and then I have to go up 4. 1, 2, 3, and in this case it's going to put me right up here. So this here is point A. For point B, I'm going to go 3 in the positive x direction, so 1, 2, 3, -4 in the y, or back in the y direction. So I have 1, 2, 3, 4, And then I'm going to go down 2 for the negative 2. So 1, 2, and that's going to put me right here for B. Now, if you do have questions on this, I will be back tomorrow and we can go over them then. Now, with a linear equation in 3 variables, we also have a standard form. That standard form is going to look similar to an equation in 2 variables, except we do add this third component. So we still have our ax plus by, but now we're going to also add that cz, and that is going to equal a constant, and in this case, that constant is d. What this does is this allows us to graph something like example 2, where it says graph 3x minus 12y plus 5z equals 30. Now the easiest way to do this is going to be to find your x, y, and z intercepts and then plot those points accordingly. So, in order to find the x-intercept, I know that y and z are always 0 on the x-intercept. So if y and z are always 0, I'm going to plug in a 0 for y and z, and I end up with 3x minus 0 plus 0 equals 30, or 3x equals 30, which tells me then that x equals 10. So I then have the coordinate point 10, 0, 0. For the y-intercept, I know that x and z are 0, so I have 0 minus 12y plus 0 equals 30. So that's going to give me a negative 12y equals 30, or y equals 30 divided by a negative 12, which is really a negative 5 halves. So I have a y-intercept of 0, negative 5 halves, and 0. And lastly, for the z-intercept, I know that y and x are 0, so I'm left with 0 minus 0 plus 5z equals 30, or z equals 6, giving me the coordinate point 0, 0, 6. So now what I'm going to do is I'm going to graph all these points and then I can connect them. So to start out with the x-intercept, I'm going to go 10 units in the positive x direction. So I have I'm going to start out here at 0, 0, 1, 2, 3, 4, 5, 6, and I'm going to run short, 7, 8, 9, 10. So I'm going to put a point right there, and we'll say that's x. Y is a negative 5 halves, so which is really 2.5. So I'm going to go and then start here at 0, 0 and move 2.5 back in the negative direction, which is right here. So this is my y-intercept. And for my z-intercept, I have 6 in the positive direction. So again, I'm going to start out at 0, 0, go 1, 2, 3, 4, 5, 6 up here. And then if you were to connect them, and I'll do that with purple, you're going to end up with something like this. When we deal with equations that have an x, a y, and a z, we can also write these equations in what we call a function of two variables. So in order to do this, what we first need to do is we need to solve the equation 4z. In other words, we need to get the z component by itself. And then we're going to replace the z with what we call f of xy. And then you should have a function with just x's and y's in it instead. And we'll look at that here in the next example. So example 3 says to write 3x minus 12y plus 5z equals 30 as a function of x and y. So in order to do that, we need to get the z piece by itself. So I'm going to go ahead and subtract 3x and add 12y to both sides. So I have 5z equals a negative 3x plus 12y plus 30. Then we have to divide everything by 5. So now I'm left with z equals a negative 3/5 x plus 12/5 y plus 6. And I got that by dividing each piece out by that 5. And our last step was to replace this z here with an f of xy. And then we're going to rewrite that as a negative 3/5 x plus 12/5 y plus 6. So this is my linear equation in 3 variables rewritten as a function of x and y. Now for part B, it tells us that we want to evaluate this function when x equals negative 2 and y equals 2. So we can write that, if you recall, in function notation as f of negative 2, 2. And what this does is this tells us that we're going to replace every x with a negative 2 and every y with a positive 2. So we're left with a negative 3/5 times negative 2 plus 12/5 times 2 plus 6. So if we go ahead and simplify this now, we're going to be left with a negative negative is a positive. 3 times 2, because this is really over 1, is really 6/5 plus 24/5 plus 6. And if I get common denominators so that we can add all this up, this here is really going to give me 30/5. So if I add 6 and 24, I get 30, plus another 30. This is going to give me 60/5, which is really 12. And for our last example, it says a family is planning a vacation at a resort. Airfare is going to be $1,200, lodging is $120 per night, and meals are $40 each. The first thing we want to do is we want to go in and write a model for the total amount that the family will spend as a function of the number of nights and the meals that they eat, because those are the things that are going to occur per day or per time. So because we're looking at how much we're spending, I'm just going to call this a cost, or C. And if we go back into our problem, we see that we spend $1,200 whether we stay there for 1 night or 2 weeks. So I'm going to include the $1,200. And it tells us that we have $120 per night. So because of that word per, I know that that means I'm going to have to multiply this by something. So I'm going to go 120x, and x is going to be our number of nights. And when we come over here to the $40 each, this is the number of meals. So because my unit of meals is different than the number of nights, that tells me then that I'm going to have to go plus 40y where y then is going to be my number of meals. So now I've come up with an equation that takes into account the number of nights I stay at my hotel cost, plus the number of meals times my price of those meals, and my airfare cost. Now part B asks us to evaluate this model for several different amounts of nights and meals and organize the results in the table. Now there's going to be a few different ways that you can do this. I'm just going to show you one, and if you have something else, that's fine as well. But I'm going to create a table, and within this table, I'm going to call this side the number of meals, and along this side, this is going to be the number of nights. So, and I'm just going to pick some random numbers, but if we do 2 meals, 5 meals, and 10 meals, and this would be for 1 night, 2 nights, and 3 nights. So what I'm going to do with how I have this set up, this is my number of meals, which if you recall is my y values, and you may even want to put that off to the side. This is your number of nights, which is really your x value. So if I go and I take this 2 here, and I plug it in for my y, and this one here and plug it in for my x, I end up with 1200 plus 120 plus 40 times 2, which is 80. So 1200 plus 120 plus 80 is going to give me $1,400 that I've spent. Okay, and I'm going to do the same thing if I plug in a 5. So if I have 5 meals and only stay 1 night, I'm now going to plug that 5 in for my y, and I'm going to come up with a value of $1,520. Same thing if I plug in a 10 for the y and a 1 for the x, I'm going to end up with $1,720. Now I'm going to change the number of nights. If I stay 2 nights, that means I'm going to be plugging a 2 in for x, and I'm going to start out with 2 meals, so that'll plug the 2 in for y, and that's going to give me $1,520. If I stay for 2 nights and 5 meals, I'm going to spend $1,640, and 2 nights with 10 meals is $1,840. Then I'm going to go down to this last row, and if I have 3 nights worth of stays and 2 meals, I will spend $1,640. 3 nights with 5 meals is $1,760. And 3 nights with 10 meals will be $1,960. So we now have a table that would kind of help assess maybe where we want to fall within our budget, how many meals we can eat, and how many nights we can stay. Again, if you have any questions, please feel free to write them down, and I will be back tomorrow and I will go over your questions then. I hope you guys have a good day, and we'll see you later. Thanks.